differential equation, yay. These are my favorite. So, what do we do with a differential equation? Well, first of all, sometimes, here we have a slope field, okay. Sometimes they actually have you draw your own slope field, like we had on the practice exam. Here, they provide it for you with an initial condition at 0, 1. Okay, so if a portion of the slope field of the differential equation is given, sketch the solution. So, locate where 0, 1 is. Well, if this is 0, 3, then right here would be 0, 1. Okay, so we're starting with 0, 1. Okay, now here is where you want to try to follow the curve. Can you see the curve? It kind of looks like a sine curve in a way. We're going to go and try to follow a path between the slope fields. Okay? So let's see if we could do this.
How do you know whether or not to go above or below?
It's just like, it's almost like you don't want to connect the dots, but you want to follow. You want to follow what looks like.
If you go above that or
Okay, so I'm gonna try to stay in this path, like between. If you, so I'm gonna go here. You want to use the upper one? Yeah. You know what? I think I will.
How do you know when to I know when to cut up. The top part would be.
I didn't do it.
Did I go too far? No. You think so?
Yeah.
Yeah, you know what?
On the, it goes up at like the third to last like V on the bottom.
Does that look better?
How can we tell like where the?
Are they gonna take points off or just like everyone
No.
Wait, does it go?
No,
It goes up?
I did it lower.
Okay, it's a.
It goes all the way below the.
It does?
It went to the like, you go down all the way.
So I should have gone down a little bit lower.
No,
Okay.
like a lot lower.
A lot lower.
Like no, like the third. Look,
Well, do you want to come up here? Do you want to come up here?
I really don't want him to.
On the free, I can't do it. But the free response, I looked at the free, the solutions manual, and it went up at like the third V here.
Really?
Yeah.
Let's see. Oh yeah, it does go way down.
And I
Okay.
couldn't figure it out. Cause like, and then, yeah. How do you know when to like cut? Cause like obviously that can happen to us.
Yeah, that's really.
That's still too high.
That's still too high?
Look, cause it's the third one.
I don't know.
If it matters, I don't know.
I don't. Yeah, see, that's not going to be. Okay. I see. This is a tough one to get perfectly. Yeah, I don't know how to get the.
Will they take points off the dollars?
No, they don't take out points.
I mean, like
They're usually pretty generous on the slope field part. They only gave you 1 point for this. So the fact that it at least, so your goal is to try not to touch any of the slope field. That's what you're trying not to do. I know it's hard. It does go a little bit further down. It's just, it's hard looking at my screen and trying to make it. It's probably easier to do on paper. Yeah, mine goes down. You know what? You're right. It should go down further like that. Okay. I'll see if I can fix it later. But honestly, this was part A was 1 point. That's it. So part B, write an equation for the line tangent to the solution curve in part A at the point 0, 1. Use the equation to approximate f of 0.2. So they want two things here. They want you to come up with your line tangent, which is really, and then use that linear approximation using the tangent line to approximate point 2. Okay, so let's start with the, well, they gave us the point, so that's easy. We just need to figure out the slope. So what's the slope at 0, 1? 2 cosine of 0, so that's 2. So it's y minus 1 equals 2, and then x minus 0. So basically 2x plus 1. Yeah, I know. Oh.
You don't really do dx evaluated at 0, 1. Sort of
They just gave you 1 point for the tangent line, but I honestly would probably do this because there are cases where they'll like, want you to identify the slope, but they didn't. They gave you a point for y equals 2x plus 1. Now, how do I approximate f of 0.2? Just plug it in, right? So 0.4 plus 1 is 1.4? Make sense? So you're just plugging in 0.2 for x to find out the y.
At the top where it says what y equals f of x, why does it
Well,
it's just like
it's just so that, it's just for notation purposes.
so we
And they
can
wrote,
y equals 1 while x equals
yeah.
0.
Yeah. Okay, part. Okay, here it is. Here's the 6-point part. So part A was 1 point, part B was 2 points, so part C, the differential equation part, was 6 points, the best part. Okay. Come on, let's. Was it because of the cosine?
Yes.
Okay, Preston asked the question, what does particular solution mean?
It means you separate the
Don't forget it.
I was so happy when
That is like, find the particular solution, right, or solve the differential equation. I put that in the haiku page that I was sharing. Those are the 2 key words that you're looking for. Solve the particular solution, or find the solution to the differential equation.
Find the solution means
Solve for y. We want to get our, so they gave us dy dx. They want us to find the original of the y equals. Okay, how do we separate this? Into 1 over 3 minus y dy and cosine of x dx. If you separated the variables, you gotta give yourself a point. Okay?
And then if we do an integral in that same step, is that fine?
So, yeah, I'm gonna put the integral at the same sign. No, if you do the antiderivatives correctly, you get a point for each side. Now, this is technically u substitution,
But it's -1.
but it's a -1 derivative, right? So you could just put a negative ln of absolute value of 3 minus y. Keep the absolute value. And then on the right side, sine x. It says constant of integration, so the bottom has a derivative of -1, so technically it's ln of absolute value of 3 minus y divided by -1. So with integrals, we divide by the derivative of the u. Oh, not really. That's as hard as they usually do.
we give them a plus c for the y.
Nope, just plus c on the right side. They know there's a plus c here and a plus c here,
Both of plus c cancel out.
but they're different constants. All right, now what? Uses initial condition. If you plugged an initial condition in, you got a point.
Wow. So what are we up to 4 points there? 2 and then 1.
So far you got, if you use the initial condition, you get 5 points. So even if you solve for y incorrectly, you got 5 out of the 6 points here. So I got negative ln, absolute value of 3 minus, what was the equation? 3 minus 1.
So can you drop the absolute value of that?
Yeah, you can. And then sine of 0 plus c. So it's gonna be negative ln of 2 equals c, right? Sine of 0 is 0. So now I'm gonna go back to this point where I integrated, and I'm gonna plug in my c. Oh, this is the best part.
It's all the best part.
It's true. It's true. It is. Okay. Now, I want to get rid of the ln. However, I got to get rid of the negative sign first. So if you have any coefficients in front, get rid of that. Okay, because we don't want to have an e to a negative power. I mean, you can deal with it later, but I think it's easier just to get the ln. So I have ln of absolute value of 3 minus y equals ln of 2, minus sine x. Now we'll do e to both sides.
Do we have to do all these steps?
Well, I'm showing all my work. The steps are necessary. Whether you show all of these steps, not really necessary. But okay, now. Right, so now we get absolute value of 3 minus y, but what is, we could separate this into e to the ln 2 times e to the negative sine x, which allows us to simplify e to the ln 2 into just 2. Yeah, let me, looks like I might run out of room. So it's going to be absolute value of this. I'll write out the steps so you can see it. We did some like this previously. If you have an ln in your power, they do want you to simplify it. So they want you to recognize that that's 2 as a coefficient. So it's 2e to the negative sine x. Okay, now what? Okay, so technically, right, so technically 3 minus y is going to be plus or minus 2e to the negative sine x, right? Plug in your initial condition, which was 0, 1.
Where's the calculator?
Oh, but it's a 0 here, so what happens here? That becomes just 2, so it's plus or minus 2, and this is 3 minus 1, so that has to be 2. So it has to be positive. But it was fun.
I'm so
A little bit?
bothered right now.
Solve for y. What do we have to do? Yeah,
No,
move
no,
the 3
no,
over,
-1.
divide by -1.
Or just move the y over.
Great. Either way, it's 3 minus 2e to the negative sine x. And note, they said note this solution is valid for all real numbers. Usually they just want you to just the domain. I've never seen them take off a point for not putting the domain, but it's like they always put it in their solutions. So if you remember to do it, maybe they'll be generous on other parts. No, I don't know. Probably not, because it's like the very last thing.
They already raised the rest of it anymore.
Yeah.
That's what they told us we're not supposed to do the back.
Did we get how many? Somebody get the differential equation one?
Yeah.
Let's do it.
So we're gonna say, what was this, thing?
That was so much fun. We have, what do we have, 15 minutes yet?
It's not so really expensive.
Oh, it's 10
55.
minutes, 10 minutes.
Oh my god.
Emma?
It made me so depressed, you have no idea.
Screencast is still running.
Oh. And, Ben and Luke, 'cause they're gonna try to join our class when they can. They have class right now. They're all.
Do they get 18 credit?
Not the class, but they'll get it 50.